Welcome to Study Loop.
This question asks us to explain how an atom can expand its valence shell. In order to discuss this, we first need to discuss the orbitals an atom can have. These orbitals include the s orbital, p orbital, d orbital, and f orbital. So these orbitals represent the space that an electron can exist in an atom, and each orbital can hold a maximum of 2 electrons. But the number of these orbitals varies, and the total number of orbitals of the same type and energy make up a subshell. So there's only ever one s orbital at an energy level, but there can be 3 p orbitals, 5 d orbitals, and 7 f orbitals. This means that the s subshell can have 2 electrons, while the p subshell can have 6, the d subshell can have 10, and the f subshell can have 14. And these are when the subshells are completely full. Now, normally when analyzing atoms or molecules for things like Lewis structures, we obey the octet rule. This means that the valence shell, or the shell that is comprised of all the subshells at the highest energy level for an atom, is full valence at 8 electrons. We can see that's when you have the s subshell plus the p subshell, or 2 electrons, plus 6 electrons. So atoms or molecules will have a full valency at 8 electrons. However, atoms that have d or f orbitals available can expand that valence shell, since they can hold more electrons than would just fit in the s and p orbitals. So we take s plus p plus d subshells. That's 2 plus 6 plus 10. They can hold a full 18 electrons before they can't hold any more. That's only with the d subshell. So how do we tell what can have orbitals? So just going by number, we can see the s orbital is the first, p orbital is second, d orbital is third, and f orbital is fourth. So by looking at the different periods in the periodic table, we can see in the first period, we have hydrogen and helium, which can only have the first orbital, which is the s orbital. But in the second period, we have oxygen and fluorine as our examples, which can hold the first 2 orbitals. So they both have s orbitals as well as p orbitals. This is still only enough to have 8 electrons, though. So looking at the third period, we have elements such as sulfur and chlorine. Now these can have s orbitals, p orbitals, as well as d orbitals. So we can see that from the third period and below, where there are even more orbitals available, we can have the expanded octet with a d orbital. So atoms such as hydrogen and fluorine cannot expand their valence shell. But elements of lower periods, such as aluminum, sulfur, chlorine, and selenium, which is in period 4 at the end there, can expand their valency.